Hello guys, hope everyone's doing okay. So I've recently been going down the rabbit hole of using Nuke as an asset artist. Just to clarify, way ahead of this video, I am not a competent Nuke user, I'm definitely not a comp artist, they will know a lot more about this stuff than me. But I've just been trying to learn the tool from the perspective of an asset creator. So most recently I've been using it to create like old photo effects, kind of grading them to be just a bit more aged looking really, to match much older photos from like 100 years ago. That's been really helpful in that other project, and that's maybe something I can break down on a different day. But just to kind of like develop my understanding of Nuke, I've recently tried to make some more utilities out of it, and the most recent one being a normal map generator. So again, quick disclaimer, this normal map generator isn't meant to replace what you have in Photoshop or what you have in Substance Designer. This is not what Nuke is built for, but it's a helpful kind of exploration, I guess, to understand the tools a little bit better. So I'm using Nuke non-commercial, which is limited to 1080p, but it's completely free, so it's fine for 1K textures. If you've got something tileable, that's great. The limitations of this setup that I've created, it will have a 1 pixel boundary on the left and bottom, or right and top of every image because of the way it works, where it's just like a value of 1 or value of 0. That would be quite easy to fix, but we're not going to go over that. And it can only convert bump maps or black and white like float maps. You cannot give this a color image and expect it to give you the same results. Obviously, if you have a way of creating a bump map from an image, this would then work on that, and maybe that's something I can look into for future versions. But anyway, that's enough babbling. I'm going to kind of recreate this setup and just kind of talk through my ideas, why I'm doing things the way I'm doing them. And if you get any lessons out of that, fantastic. If you don't, then that's also fine. It's still kind of fun to play about with this stuff and try to learn it. But anyway, so first off, we're going to create a bump map, which, because I don't obviously have an asset I'm doing this on, I'm just going to create a noise. Now, this noise is 0 to 1. It has an alpha channel, which also is part of that 0 to 1. I generally like to just create a shuffle and shuffle a value of 1 into the alpha just to make the image completely solid. You can do that in the noise node itself. I just generally quite like to do this stuff visually using a shuffle node. And we've immediately hit a roadblock. What is a normal map and what is a bump map, and how can you get one from the other? Well, first, a bump map is a black and white monochromatic map, which typically goes 0 to 1, but it can technically go below 0 and above 1. But it describes the height of a surface. So if you get like a flat plane and put a bump on it, it's saying this pixel wants to be higher than this pixel. The nice thing with bump is you can plug it into displacement and it will do the exact same job. Normal maps, however, they don't describe the height of a surface, they only describe the angle of a given pixel. So what way is this point facing? Because it's not facing up anymore. This has its advantages and is primarily used in the game industry, but they're still fundamentally quite different techniques. So how can we actually get one from the other? Well, if you think of it this way, when you look at a mountain could be described with a bump map by having a white peak and black kind of valleys on either side of it, and the grey values obviously tell you how quickly it gets to the peak. So if you were to look at a mountain from the side, well, even though you know its height, you could still figure out its angle by just comparing one point to another. So if I say, hey, the peak is 1,000 meters and a meter to the right of it is 998 meters tall, you could find out the angle of that just using a little bit of maths. You can do that in Nuke as well, but we need to figure out how do we compare a point to something that's like a pixel to its neighbor pixel. Well, the easiest way is using merge nodes and transforms. So I'm going to create a transform, and I'm going to move this image 1 pixel to the left. So that's all I'm doing, a single pixel. If I view it, that will help. It's literally just the tiniest shift. But that now gives me the ability to actually compare pixels to each other. So if I create a dot node here, would have been quicker to just control click, but let's just create this. I'm going to create a merge. And let's just neaten this up a little bit. So this merge, set to merge over, because of this solid alpha, it actually doesn't change visually. It's the same no matter what you do. If I set this to minus, what we're now going to get is, it's going to tell me, in essence, where is it facing to the right. The way it's doing that is, because I've moved this image to the left, if the value of a pixel has gone up, then we know, or sorry, if the value of a pixel has gone down, then we know that that bump map would have resulted in something that's facing to the right. So that's what this is giving me. It's telling me, hey, these pixels have moved to the left. This is decreased in value, so we're going to get this slight right facing. The nice thing about it as well is it's giving you a different value per pixel. So we're essentially getting like every different angle change. It's not just saying, hey, it's lower now. It's saying by how much, which is actually all the information we need to create normals. The problem now we got is it's only telling us that it's going to the right. We could copy paste this and change that transform to move everything to the left, but then what you're going to get is a seam down the center where everything is an extra pixel wide. So what I'm going to do instead is change the blend mode. I found that the from blend mode works quite well, and what this now does is tells us, okay, it's moved to the left, has the value increased or decreased? If it's now increased, it will tell us by how much. So if we look at these two textures, we're seeing how they're actually fundamentally quite different. It's not just a mirror image, it's actually a different map. So we've actually now got everything we need to create some normals. So I'm just going to create a merge, and I'm going to plug the B pipe into that from merge, and I'm going to connect the A pipe to the minus merge. This I'm now going to set to minus. And what this has now done is anything that was facing to the left has been subtracted from the map that was telling us if something was facing to the right or not, which results in having negative values as well as positive values in the map. You can see just down here, I've got negative values here, which tells me it's facing to the left. Positive values tells me it's facing to the right. So a value of 0 would imply that it's facing perfectly at the camera. So that's obviously all well and good, we got the information, but it's kind of unusable right now. We can't save this out as a texture without using 32-bit. So we just need to offset this. So I'm going to grade it. This grade is just going to offset by 0.5. And we now have everything in 0 to 1. Now, it looks like a flat grey square, and obviously after YouTube compression it definitely looks like it's flat grey, but there is actually still information here. It's just very, very subtle. Again, you can see just down here at the bottom. Very subtle. So we want to create another grade node just to add some extra contrast to this. So I'm going to create a grade just here. And I'm going to set the black point to 0.47. I'm going to set the white point to 0.53. So we've now got all our contrast back. If I set these to different numbers, I'd have more or less contrast. If I set these numbers too high or too low, we start to get clipping. So if I set this to 0.49, we're getting a lot of pixels now which are a perfect black value, which is junk information. This doesn't really tell us anything other than it is facing 100% to the left, which we know it wasn't. So I'm just going to set this guy back to a value that means we have all of our value ranges in there still. So we got that. So that's our left and right, but now we need up and down. But as you're probably aware, with this being a node-based workflow, we can just duplicate this and change one thing to make it capture our left and right values, up and down values, sorry. So this transform was getting our direction, so all we need to do now is grab this transform, and rather than 0, I'm going to set this to -1 up and down. Now, I've missed that grade, so I'm going to have to bring that over here. But you can see how now we've got up and down as well. So let's just grab these in here. Just make sure that we've done both of those. -1 in that direction. There we go. That's better. So we got our up and down, where whiter values are facing up, blacker values are facing down. And we got our left-right, where darker values are facing to the left, and brighter values are facing to the right. So this would actually give us an OpenGL normal map, which is what's used in basically all 3D software that isn't games based. Game uses DirectX, or generally use DirectX normal maps. But this is still not a usable map, right? It's 2 individual black and white maps. So if you didn't know this, it's quite a helpful thing to know about. The normal map is 3 different bits of information. I'm going to ignore the blue channel because honestly I don't fully understand it. But the red channel tells you what's facing left and right, and the green channel tells you what's facing down and up. So we can do that with a shuffle. We can just grab these 2 channels. I'm going to grab this B pipe, put it into there. Grab this A pipe, put it into there. And this will allow me to connect these 2 together. So I'm just going to set this to A. So we want our red channel to be the left and right, which is coming from our A pipe. So it's going to do that. And we want our blue channel to be white. And there we go. We have a normal map. So that's pretty much it, to be honest. It's actually quite a simple process. The only kind of difficult thing was kind of figuring out how to compare pixels next to other pixels, which took me longer than it should have, to be honest. But it's a helpful little tool to have. One thing you will notice is because it's only moved by 1 pixel and detects any amount of change, this is an incredibly sharp map. It picks up everything, which may not be what you want. So if you want a softer normal map, what you can do is create a blur just here. And what that blur will allow you to do now is compare pixels on a softer map, therefore giving you a softer normal. So this is a very helpful tool if you want to do like kind of detail normal maps and non-detail normal maps. If you want a lack of detail, you increase this. If you want a lot of detail, you decrease it. And obviously you can do some maths if you create this twice, get a difference between them. You can separate your details from your high, from your low frequency information. So what if you wanted to create a DirectX normal map where the green channel is inverted? So obviously we can just invert the green channel, but I think a much more interesting way to kind of get this in our heads is using this transform just here. So if I set this transform to move in the opposite direction, if we ignore the moment where it breaks, we can now see how this green is now telling us which way is pointing down, or actually is telling us which way points up in DirectX. I had to do that twice, so this is where I become incredibly lazy. Because I got 2 transform nodes, obviously I could just connect this up here, but that looks really messy. So what you can do instead is just grab this value, copy links, and go to our transform, over transform, sorry, and go to paste relative. That creates kind of this like virtual link, where if I change this to like 10, this is now set to 10. It also makes the normal map more sensitive, but we can very quickly invert the direction of this map now, and we can do the exact same thing with our left and right, but I wouldn't recommend that because that isn't really how normal maps work. But yeah, so that's kind of it, a general setup. There are obviously many ways to build on top of this. There are definitely issues with it. Again, there's our 1 pixel issue here. We could obviously crop that final pixel and then extend the edges back out to kind of get rid of this junk data. So that again is the limitation of the workflow, but it works quite well, and it gave me a chance to kind of learn a little bit more about using Nuke within an asset artist kind of mind frame, or mindset even. But yeah, anyway, I hope this has been helpful for you, or have learned something. But yeah, I'm just going to move that Z, and we can see how it's updating pretty much in real time as well. It's nice and quick, and obviously we can use this in any bump map now. But yeah, anyway, hope you've learned something. I know I learned a few things trying to figure this out. If you have any suggestions for improvements, by all means let me know, because I'm still, again, very, very new to Nuke. and the quicker I understand this fully, the better, really. But yeah, hope you enjoy the rest of your night, guys, and I'll see you in the next video. Bye.